We are going to start a new section, and that is section 2.5, solving trigonometric equations. Well, as opposed to what? As opposed to the algebraic equation you guys have been solving in college algebra or other classes. What have you learned there? Either to solve a linear equation like this, or you solve it in that fashion, or you have a quadratic equation. And let me see if I can get a chorus on what is the solution of the quadratic equation. X in terms of A, B, and C is given by what formula? Minus B plus or minus. Of course, there are infinitely many varieties of equations. We don't have formula for each one of them. We have formula really for very few. For linear, quadratic, there's a formula for cubic, but kind of fills up that board. Or quartic, even more complicated. After that, something magical happens. There is no formula of this type, nothing of this nature you can cook up to solve equations of degree 5 or above. So as far as these kind of equations concerned, our limitation shows itself rather quickly. We have to invent things to solve them. Now we are going even beyond that category. We are looking at equations that have trigonometric functions included in them, meaning that quantity that you are looking for is inside a trig function. So the complications are going to add, and we are going to combine whatever we have learned from trigonometry and whatever you guys know from college algebra to solve a few trig equations. We are going to start with very basic ones, which is going to set the tone. Suppose I ask you solve sine of theta is equal to 1/2. Describe all angles several ways we have to approach this. As usual with trigonometry, we have redundant ways, and we use them simultaneously to make sure we are always on the right track. The answer that you are most familiar with, the angle that you know, whose sine is 1/2, is what? Yeah, pi over 6 or 30 degrees. So one answer is, but the main issue in this section is that there are many answers, and we want to nail down all of them. The one that you give really is coming from definition of inverse sine, but there is the rest. To give that answer, let's first approach this by graphing. Suppose I go ahead and graph sine of theta. Let me try again because I want to put my picture in the middle. So I define a function. So y is equal to sine of theta. Horizontal axis, I take it to have a name of theta. I remember what the graph of this thing looked like, so I try to make a good Okay, that's y equal to sine of theta. When you say sine of theta is equal to half, it means what? It means the output turned out to be half. So I pick that half. So this is 1, and you want to be at 1/2. You're asking what angle did I start at so that by the time I came up, I reached a height of 1/2. So go ahead, draw a line at 1/2. See where you might have come from. Okay, this is one place you could have come from, which is, let's go with degrees. How many degrees is this one? That's just 30 degrees. But then there is another angle where the sine is 1/2. What is that one? No, 330. You probably are trying to use the unit circle at the same time as you are talking about this. Let's have both discussion running simultaneously. We said we have a unit circle that helps us a lot with our investigations of trig functions. If you have an angle, you want to find the sine of it, you go straight across to the vertical axis. This is the sine of it. Now, the issue of interest is if you were here, if the angle was this, the sine of it would be the same. And so this is a possible answer. So is this one. Or if I had decided to go around the circle, come back and hit this line, that would be another possible answer. And so on. We have other possibilities, but I guess the picture gets crowded. Those possibilities correspond to this. You want to reach a height of 1/2, you could have started at 30 degrees and make it to a half. You want to get to 1/2, here's another option that you have. So let me redraw my picture. Here is, I go on the vertical axis, the sine axis. I pick 1/2 over there. Here's 1/2. I draw a horizontal line here. I ask, what angle is this? Well, that's at 30 degrees. What angle is this one? 150. That is simply the supplement of that. So the other location is this, 150. Now, this cycle, I have to cut it short. Suppose I could have gone further and start from this location. What angle do you think that one is? That corresponds to not stopping here, but going all around, coming back, 390. So here are, other than 30, we have 150. After that, it becomes predictable because you have to make an entire rotation and come back to the same angle. So the other one was 390. How can I get 390 out of 30? At 360, because you're just saying go one more circle. That will be easier than looking at it like this. How about this one? What does that one lead to? I can stop at 150, or I can go one extra rotation. So I can go here, go back 360, and then come here. So 360 added to 150, what's that going to be? 510. You can go backward. Yeah, that would be our next step, is how to summarize all of these things. Let's here's a unit circle. I know these two fundamental solutions. One of them is 30, one of them is 150. I'm cooking everything out of those. So suppose I start from here and go backward and arrive at that angle. What angle is that? Negative 330. Before I go all the way, what if I had stopped here? What is that one? Negative 210. How can I get these? From 360, from 30, if you back up, say 30 minus 360, I get to this. 150 minus 360, I get to minus 210, and so on. So we have infinitely many answers because this blue line cut my picture at infinitely many points. How can I list all of them? So let's make it abbreviated. So again, suppose I have sine of theta is equal to 1/2. I say one answer is 30. Its supplement is 150. I can take each of them and then move a whole circle. Whole circle is 360 times n, meaning n is the number of rotation I'm making. It could be positive or negative, so n could be no rotation at all, one rotation in positive direction or one rotation in negative direction, or plus or minus 2, or plus or minus 3, and so on. These numbers, we call them integers. Whole numbers plus 0 plus negative of whole numbers, they make the integers, sometimes shown by letter Z with a funny thickened line. There's another listing. It's 150. You start at 150 and then you go a certain multiple of 360, as many as you want, and that gives you the other possibility. These two, they are supplementary. Always you get well, when x is positive. So let me erase that. So let me erase that supplementary so that. Well, I looked at the case of negative angles, and then we have a problem that they don't add up to 180. Let's see. Let's check it out. Suppose we take sine of theta is equal to minus 1/2. What are my angles? Give me an angle. So let's approach the problem again in several ways. You can do a unit circle. Say on the unit circle, where was my sine axis? This is my sine axis. Where is minus 1/2 on the sine axis? Here is minus 1/2. How do I handle this? I want to find the angle whose sine is minus 1/2. I go. So here are two possibilities. One of them is, now you can rotate any number of ways. Easiest way is just to look at that. And the other solution is this one. So one answer is how many degrees? Well, we are going in this direction. So minus 30 and minus 210. Sorry. Thank you. So minus 30 degrees and minus 150 degrees, these are the two angles that we have here, and Now, you could have gone in the positive direction. This one would have been at what angle? It would have been at 210. If I go this direction, what would be my angle? We're going 180 plus 30 becomes 210. If you go all the way here and turn around until you hit this point, what do you get at that situation? 330. Now you can say the sum of these guys is 180. They will be supplementary, but then you have to pick the right combination to make them, you know. So yes, these two are supplementary. But if somebody had said minus 30 and minus 150, that would be an issue, that they don't add up to 180, they add up to minus 180. So there are always two that are supplementary, but if somebody gives you two solutions, those two solutions don't have to be supplementary. So let's handle some cases with respect to cosines. Say, suppose I have cosine of an angle is, say, radical 2 over 2. We want to find all theta. Again, we have three things at our disposal. Draw the unit circle. So the horizontal axis is our cosine axis. Radical 2 over 2, that's about 0.7. So some angle has its shadow here. This is radical 2 over 2. What is the angle? Well, we can say right off the bat. The angle could have been here, whose shadow came down to this, or the angle was down here and its shadow came to the same point. What are these angles? I could go this way, the easiest one. Theta turns out to be how many degrees? 45 degrees, or pi over 4. Or I could have gone in the negative direction, in which case theta would have been what? Just minus 45 degrees, or minus pi over 4. Now, as usual, you can go around the circle as many times as you want and then stop at that location. Meaning, you could have started here, go around the circle, whole rotation, and come back here and stop. In that case, what would be your angle? 45 makes 405. So you can start with 45 and add any multiple of 360 to it. You'll be still okay. Same story with minus 45. You can start at minus 45 and add as many rotations as you want. That angle would be just as good. So those are all possibilities. Some of the problems in the book says list all the angles between, say, 0 and 720, or list all angles between 1000 and 2000. So you have to sift through this and just pick the ones that fit that description. Another alternative we have for answering this is with respect to with use of the pictures. You take your cosine. You get the value that you have. So here we have radical 2 over 2. So we go pick radical 2 over 2. Whatever number we have, we translate it to this picture. Then we draw a horizontal line here. And watch for crossings. So I have one crossing here. That is my 45 degrees. I have another crossing here, which is minus 45 degrees. Of course, I have crossings here and here as well. I can go from this one to that by adding 360. I can go from this one to that one by adding 360. So these patterns repeat themselves. You want to reach that pattern, you have to add 360 to make your way to it. Let's do an example of a tangent as well, so that we have covered all the bases and ready for doing some advanced examples next time. Suppose I ask you to find solutions of tangent of theta equal to 1. So the famous angle you know, whose tangent is 1, is what? Let's stay 2 degrees, 45 degrees. The question is, what are the other possibilities? Again, several different approaches. One is with the unit circle. So here's my unit circle. I have a tangent axis. Here's my tangent axis. I call that tangent. On that tangent, I go pick 1. Remember, radius of the circle is 1, so this is just 1. Once you pick that, you go to the origin. Here, you have one crossing here, one crossing here. These are your solutions. This is one angle. This is the other possible angle. The first one is always easy. The first one is the angle your calculator is going to give you, or you remember from the inverse trig function. The question is catching the second one. So in this case, the second angle is what? How much extra do I need to go to make to the second angle? Extra 180, so makes it 225. Now suppose I didn't stop there, I continued and came here. What is this one? I have essentially gone through a whole circle, an extra 45. So what is that? So I can get all of these things by starting at 45 and just going multiples of 180. So the way the answers for tangent equations show themselves are different from sine and cosine. Sine and cosine, you have 2 fundamental answers, and then you add 360 to them, and then you go wherever you want to go. With tangent, you get one answer, either from memory or calculator or inverse trig functions and such. You get the inverse tangent function, you get that. But remember, the period of tangent is 180 degrees. If you go 360, you'll be missing these guys. So you answer those type of questions with tangent like this. So you practice the first few of problems on section 2.5, and for more advanced ones we are going to practice it tomorrow. Make sure you practice other equations as well, section 2.4.